Assalamualaikum. Hi everyone. How are you? I hope everyone is fine. Okay, so we're going to kickstart our class this week. I hope everyone is ready. To kickstart our lecture, we're going to start with the grinding topic. There are two main topics in our class, which is grinding, and another one is related abrasive processes. First of all, let us look into what is abrasive machining. So abrasive machining is one of the material removal process where the action is taken by the hard abrasive particle. Usually this hard abrasive particle is in the form of bonded wheel. For the abrasive machining, usually it is used for the finishing operation where the conventional machining is first used to get the certain shape that we want, and then we finish it by the finishing operation using the abrasive machining when you want a very good surface finish. Grinding is most common abrasive machining compared to the other process, but we will look into other process such as the honing, lapping, super finishing, polishing, and buffing later on. Now, let's see why abrasive processes are important. The first one, it can be used on all type of material. You can use it on metal, you can use it on woods, you can use it on glass, and many more. Okay. The second one, you can produce extremely fine surface finish up to 0.025 micrometer, which is very important because not many processes can produce this kind of surface finish. And then the third one, it can hold dimensions to extremely close tolerance, which is not possible in the conventional machining. Okay, let's go to the grinding process. Grinding process is a material removal process done by the bonded grinding wheel at the very high surface speed. There are two type of grinding wheel that most commonly used. The first one, this one, is usually used in the workshop, and another bigger machine is like this one, usually for a bigger production using this one. The left picture show the most common grinding wheel used in the factory or in the workshop. Okay, so this one is consists of abrasive particle and bonding material. Okay, so what we will see if you look the grinding wheel under the microstructure, it's going to be grain. Grain is the abrasive part, and then there will be pores, and also there will be bond material also around the grain, around the abrasive particle. Let's see the grinding wheels parameter. There are several of parameters that you have to know about the grinding wheel. The first one is what is the type of the abrasive material. Second, the grain size. Third is bonding materials. Fourth is wheel grade, and the fifth one is wheel structure. Now, let's see the abrasive material properties that we want. The first one, we want it a very high hardness abrasive. Second, it has the wear resistance, and the third one is toughness, and the last one is the friability. What is friability? It is capacity to fracture when the cutting edge is dull, and then it exposes the new sharp edges. Now let's see the traditional abrasive material usually used for the grinding wheel. The first one is aluminum oxide, which is the most common abrasive. And then this one, aluminum oxide, used for the grinding of steel. Okay, so it used for the grinding of steel and other ferrous high strength alloy. And then we have second one is silicon carbide. It is a little bit harder than the alumina, but it is not as tough. Usually this one used for metal that is not so hard like aluminium, brass, and stainless steel, and some cast iron and certain ceramic. So newer abrasive material, there are two types, which is cubic boron nitride or CBN. It is very hard, but also very expensive. So this one is suitable for steel also. And then it used for hard materials such as hardened tool steel and aerospace alloy, so which is require a very hard material to do the grinding process. And another one is diamond. It is even harder but very expensive. So this one a very usually is a material that occur naturally. Okay, so it's made also it can also made synthetically. Okay, so this one is not suitable for grinding steel because it's very brittle. So this one used on hard abrasive materials such as ceramic, cemented carbide, and also on glass. The hardness of the abrasive material is measured using the noob hardness. Okay, so let's compare the noob hardness of each type of abrasive material. Okay, if you can see the first one, aluminum oxide is around 2100 noob hardness. Silicon carbide a little bit harder, which is 2500 noob hardness. And CBN, if you can see, is double the silicon carbide, which is 5000 noob hardness. And diamond, synthetic diamond, it is even more, which is 7000 noob hardness. For grain size, small grain size produce better surface finish, and larger grain size permit larger material removal rate. For hardened work material, it is required to use small grain size to cut effectively. If larger grain size is used, the grain will break during the process. Therefore, it is required to use smaller grain. For softer material, we use a larger grain size to permit the larger material removal rate. Measurement of the grain size is called grid size. It is measured using the screen mesh procedure. So, smaller grid size indicate by larger number screen mesh procedure and vice versa. So, for example, 8 is considered very coarse while 250 is considered very fine. Next properties is the bonding material. So, for the bonding material, it must withstand the centrifugal forces and high temperature, of course, because during the grinding process, the temperature of the material will start to increase, and the surface contact also will cause temperature to increase, and also the centrifugal force also will be very high. So it also must resist shattering. So meaning that we don't want the abrasive will shatter instead of do the cutting on the material. And also it must hold the abrasive grain rigidly in place for cutting, yet allow worn grain to be dislodged to expose new sharp grain. This picture shows the typical structure of a grinding wheel. In here, what we have is the abrasive, pores, and also the bond material. If you can see, this is the abrasive, and this white things is the pores. Okay, and then we have also the bond material which connect the grain together. The volumetric proportion of the wheel structure is shown in this equation. Okay, so what we can see is the volumetric proportion for the grain, volumetric proportion for the binder, okay, the bond, and also the pores. If we add it together, it is equal to 1. So next is wheel grade. So wheel grade indicate the bond strength in the retaining the abrasive grain during the cutting process. So this one is depending on the bonding material in the wheel structure. So the scale is from soft to hard. So for soft wheel, it lose grain easily. So that's why it used for the hard work material for low material removal rate. And for the hard wheel, it can retain the grain. Therefore, it can be used for high stock removal rate and soft work material. Grinding wheel have their own specifications. So there is a standard grinding wheel marking system to design to show the abrasive type, grip size, grade, structure, and bond material. For example, A46H 6V. So we are going to see on this one. And there are also additional identification for the grinding wheel manufacturer. So now let's see on the grinding wheel specification and how the marking system for the grinding wheel is done. Okay, so let's say for example the number is 30A46H6VXX. Okay, so what are the meaning for these all numbers and alphabet? Okay, so the first one is 30. 30 is the manufacturer symbol for the abrasive. Okay, so different manufacturer might have different prefix. For A is abrasive type. For example, A is aluminum oxide, C is the silicon carbide. And then 46 is the grain size. Coarse will be from 8 to 24, medium from 30 to 60, fine is 70 to 180, and very fine is 220 to 600. Okay, the next one, the H. H is the grade. So this one is to mention whether it's soft or hard. So A is soft and it go to M is medium, Z is hard. Okay, so next is 6. 6 is the structure. So this structure is range from 1 to 15. 1 is very dense structure and 15 is very open structure, meaning more pores inside here and less pores for the 1. Okay, so for the V, V is the bond type. So bond type is B is resinoid, BF resinoid reinforced, E shellac, R rubber, RF rubber reinforced, S silicate, and V vitrified. Okay, the most common one and the most used is the vitrified. Okay, so we are going to see the type of this bond type in the next slide. Okay, and the last one, XX, is the manufacturer private marking. So for those who use the wheel grinding wheel a lot, they will know if there is a marking for certain for certain manufacturer, they already have their own private marking. Okay, so here is the bond type. We have vitrified grinding wheel, we have resinoid grinding wheel, rubber, metal, and also electroplate grinding wheel. Then there are a lot more. This is just an example. So the most widely used is the vitrified grinding wheel, and here are the features for the bond type. This one you can read on the type of the bond. Now we go for the grinding wheel shape. There are 4 common grinding wheel shape. The first one is the straight one. Second is the recessed 2 side. So there is some area over here, if you can see, compared to the straight one. Okay, and then we also have metal wheel frame with abrasive bonded to outside circumference. So meaning that this part is a metal and only certain thickness of abrasive is attached to the wheel. Okay, and the last one is the abrasive cut of wheel. So this one is very thin, is used for cutting the material instead of getting the surface finish. So mostly grinding operation is performed to achieve good surface finish. So as a recommendation for best surface finish to achieve, it is recommended for small grain size to be used with high wheel speed and also dense wheel structure. So meaning that more grids per wheel area during the process. Okay, so that's the end of our lecture today. I'm very grateful if you can give me feedback on this lecture. If you have any concern or you have any improvement or idea that I can improve on the lecture, you are most welcome. I'll give you the link in the Google Classroom, so you can just fill in and submit. Okay, that's it for today. Thank you very much for listening to the lecture. See you in the next class. Bye bye.